Hello friends, in this video we are going to see the summation of the natural number, summation of the squares of the natural number and the summation of the cube of the natural number. In the 10th standard you have learned one formula that the sum of the n natural terms is n into n plus 1 upon 2. Therefore summation of r, where r is equals to 1 to n, is equals to n into n plus 1 upon 2. And the next is summation of the r square, which is where r is equals to 1 to n is n into n plus 1 in bracket 2n plus 1 upon 6. And the summation of the r cube, where r is equals to 1 to n, that is it is a n into n plus 1 upon 2 whole bracket square. All the examples are very easy. I hope that you will understood whatever that I am explaining here. Also some answers of some questions are not matching with my answers, but I have tried to solve in very accurate manner. Therefore, some answers are not matching the answers of my. I hope that you will understood all this. Now let us start the last exercise. That is, we are concluding this chapter 2.6 exercise. Let us start. Now start the last exercise, that is a properties of summation. Properties of summation. In this video, we will see the summation of the natural numbers, summation of the square of natural numbers, and summation of the cube of the natural numbers. The first is r is equals to 1 to n, summation of the constant k into tr is equals to k summation r is equals to 1 to n of tr, where k is not equal to 0. Second, summation r is equals to 1 to n ar a suffix r plus b suffix r, which are the constant, that is r is equals to 1 to n a suffix r plus summation r is equals to 1 to n b suffix r. Now the next is, third is summation r is equals to 1 to r is equals to 1 to n, summation of 1 is equals to n, and fourth one, summation r is equals to summation r is equals to 1 to n of the constant k is equals to k into summation, that is, a k means what, 1 into k, that is 1 to n of the k is equals to kn, summation of the 1 is k, where k is not equals to 0. Now result 1 that is the sum of the first n natural number that is sum of the first n natural numbers r is equals to 1 to n into n plus 1 upon 2. This is the formula which we will use mostly. Now this is the basic for this exercise. Number of the students say that sir, take the basic of that chapter, but this is the basic. And whenever I explain each and every exercise in a very detailed step, what formula use here, and some calculations are there. Up to the 10th standard you have done it. Result of the sum of the squares of first n natural numbers, that is summation r is equals to 1 to n, r square is equals to n into n plus 1 in bracket 2n plus 1 upon 6. And the last very important formula, that is the result. This is the third result. The sum of the cubes of the first n natural numbers, that is nothing but n into n plus 1 upon 2 whole bracket square. First n natural numbers, summation r is equals to 1 to n, r cube is equals to in bracket n into n plus 1 upon 2 whole bracket square. These are the three results. Now the above results can be proved using mathematical induction. That is in the next chapter. We can prove that result. In chapter number 4. Now we'll start the last exercise, that is exercise 2.6. Again, all the problems are not so easy that you have learned in the 10th standard. These all problems required too much practice, full concentration, then and then you will become expert in this chapter. Find the sum r is equals to 1 to n in bracket r plus 1 second bracket 2r minus 1, that is the summation r is equals to 1 to n r plus 1 into 2r minus 1. Now we will make their product, that is the summation r is equals to 1 to n. First is 2r square minus r plus 2r minus 1 plus 2r minus 1 r 2r square minus r plus 2r minus 1 bracket complete. Now evaluate this. Summation r is equals to 1 to n 2r square plus r minus 1. Now this can be written as summation of the r is equals to 1 to n to outside. That is the summation of the 2r square, where 2 is a constant. Therefore 2 into summation r is equals to 1 to n into r square plus summation of the r is equals to 1 to n minus summation of the 1. Now 2 into summation of the r square. Now we will substitute the value of r. That is n into n plus 1 in bracket 2n plus 1 upon 6 plus n into n plus 1 upon 2 minus n. Now the simplification. This simplification is different from the textbook. Now see this. That is a 2n in bracket n plus 1 in next bracket 2n plus 1 upon, by find out the LCM. Then second is 3n in bracket n plus 1 minus 6n upon 6. Now from these two terms, that is we will take the common n into n plus 1 in bracket 2 in bracket 2n plus 1 minus plus 3 bracket complete minus 6n divided by 6. Now again their simplification, that is n into n plus 1 in bracket 2n square, that is a 2n 2 into 2n, that is a 2n plus 2 plus 3 minus 6n upon 6, and that's why the simplification is n into n plus 1, that is n square plus n in first bracket, and second is 4n plus 5 minus 6n upon 6. I forgot to write the 6 there. Therefore it is a n cube plus 5n square plus 4n square plus 5n minus 6n divided by 6 in the second. Now I am changing it 6. Now the normal simplification is there, n cube plus 9n square for n cube plus 9n square minus it is a minus n it is a, there is a sign is a minus sign is there, I am changing it. That is a minus 1 upon 6. Therefore n in bracket 4n square plus 9n minus 1 upon 6. This is the sum, n in bracket 4n square plus 9n minus 1 upon 6. Now next is second summation r is equals to summation find summation r is equals to 1 to n of 3r square minus 2r plus 1 bracket complete and the summation r is equals to 1 to n 3r square minus 2r plus 1. Therefore, substitute the values. 3 into summation r is equals to 1 to n of r square minus 2 summation r is equals to 1 to n summation r and plus summation of r is equals to 1 to n of the constant, that is 3 summation of the r square is n into n plus 1 plus 2n plus 1 upon 6 n into n plus 1. Next bracket is a 2n plus 1 upon 6 minus 2 summation of the r n into n plus 1 upon 2 plus summation of the 1 is n. Now simplify this, that is n into n plus 1 into 2n plus 1 upon 2 minus 2n into n plus 1 upon 2 plus n, and in this way we can subtract it because the base is same now, that is a n into n plus 1 bracket complete 2n, that we had done, that is the n into n plus 1 is common, that is the 2n plus 1 minus 2 that is the first is minus 2 and the last term is 2n because we are multiplying also n by the 2. Now simplify this, n square plus n in the first bracket and second bracket is 2n minus 1 plus 2n upon 2, there must be 2. I hope that there will be the correction, that is again the multiplication divided by 2 must be there. I am changing it upon 2. Now simplification, again we are doing the multiplication. Therefore it is a 2n cube minus n square plus 2n square minus n plus 2n upon 2, and that's why we are getting 2n cube plus n square plus n upon 2. Now again we can take n as common, then we will get 2n square plus n plus 1 upon 2. Now the next problem number 3, summation r is equals to 1 to n 1 plus 2 plus 3 plus r upon r. Now the summation r is equals to 1 to n. Now there is a summation of the 1 plus 2 plus 3 up to the r, therefore we will treat it as like this, summation I is equals to 1 to r of items. that is upon this whole divided by, there must be the items, and summation r is equals to 1 to n, and in bracket we will get n into n plus 1 upon n into n, r into r plus r into, that is in bracket r into r plus 1 upon 2, and whole divided by r, that is r get cancelled, r in bracket r plus 1. In this case there is a double summation because the term is r. Now see this, due to my pen it is not in a stable state, it moves ups and downs, that's why my page is moving ups and downs. That is summation of the r is r into r plus 1 upon 2 upon r, that r get cancelled, and overall we are getting summation r is equals to 1 to n r plus 1 upon 2, and that is equals to 1 upon 2 in bracket summation of the r is equals to 1 to n plus summation of r is equals to 1 to n of the constant, which is 1. Summation r is equals to 1 to n of the constant. Now substitute the values, that is equals to 1 upon 2 in square bracket summation of the r is n into n plus 1 upon 2 plus n bracket complete, and that is multiplication 1 upon 2 n into n plus 1 plus 2n upon 2, and that's why you will get n into n plus 1 plus 2n upon 4, n into n plus, that is we will take the n as common, then you will get n plus 1 plus 2, and that is upon 4, n into n plus 3 upon 4, and this is the final one. Now the next is n into n plus 3 upon 4. Now the fourth problem, find next problem, summation r is equals to 1 to n, that is the summation I 1 cube plus 2 cube plus dash dash plus last is r cube, and this whole divided by r into r plus 1 bracket complete. Now again we will find out the internal sum, means that in outside bracket there is a summation r is equals to 1 to n, but again there is one more summation in the internal square bracket, that is 1 cube plus 2 cube plus dash dash plus r raised to 3 r raised to 3 . Now we'll write that r raised to 3 upon r into r plus 1. Now again we'll find out the summation r is equals to 1 to n. Summation r is equals to 1 to n. Summation I is equals to 1 to r of I cube upon r into r plus 1. Now find out the summation of the r is equals to 1 to n and summation I is equals to 1 to r of the I cube is r into r plus 1 upon 2 whole bracket square. R into r plus 1 upon 2 whole bracket square. This divided by r into 1 upon r into r plus 1, that is a denominator term. Therefore, summation r is equals to 1 to n, r is equals to 1 to n. The terms will be get cancelled, that is r into r plus 1 upon 4. Take 1 by 4 as a common. Summation r is equals to 1 to n r square plus r. Now find out their sum, then you will get 1 by 4 summation of the r square, that is r is equals to 1 to n of the r square plus summation of the r is equals to 1 to n. Therefore 1 by 4 in bracket summation of the r square, that is nothing but the n into n plus 1 into 2n plus 1 upon 6 plus summation of the r. What is summation of the r? That is n into n plus 1 upon 2. That is 1 by 4. 1 by 4 is multiplied with the two terms of the brackets, that is 1 by 4 into n plus 1 upon 2, and after simplification we will get, that is a n into n plus 1 into, that is a upon 8. Now we are taking as a common from these two terms, which is common term, n into n plus 1, n into n plus 1 upon 8 in bracket 2n plus 1. The remaining term is, that is a 2n plus 1 and the next is, that is I am again writing by performing their LCM, that is n into n plus 1 in 2n plus 1 upon 24 plus n into n plus 1 upon 8, n into n plus 1 upon 8, and in bracket we will get 2n plus 1 upon 3 plus 1, bracket complete. Now simplify this, n into n plus 1 upon 8 into 2n plus 3, 2n plus 1 plus 3, 2n plus 1 plus 3 upon 3, upon 3. Therefore n into n plus 1 upon 8. In next bracket 2n plus 4 upon 3, 2n plus 4 upon 3, and this is the final. Therefore we have n into n plus 1, 2 in bracket n plus 2 upon 24. That is n into n into n plus 1. Now there is a problem in writing. N into n plus 1 into n plus 2 upon 12 n into n plus 1 into n plus 2 upon 12 into n plus 2 upon 12. Now the next is problem number 5. Find the sum of 5 into 7 plus 9 into 11 plus 11 into now this problem is a different one, but I had taken that is a 5. First term is 5, then 9, then again 13. This type of the sequence must be there. That is a 5 into 7 plus 9 into 11 plus 15 in 13 into 15. This type of the problem must be there because the first term is 5 into 7 and second is 9 into 11, and in this way the terms must be like this. Therefore I had corrected this. If you are agree, then no problem. If you are not agree, then see this what I had solved there. I had taken this type of the problem. You will get the confusion, sir, you have done like this and given is like this, but I am considering this type of the problem there. Each term of this series is a product of two numbers. Now see, the first number is 5, 9, 13. The first number is 5. Is the product. First number is the products are the 5, 9, 13, and in this case the first term a is 5, common difference is 4, and therefore we can find out their rth term. See this? They form arithmetic progression whose first term a is equals to 5, common difference d is equals to 4, hence the first number in the rth product is that a t suffix r is equals to a plus r minus 1 into d. A plus r minus 1 into d. where A is 5 plus R, D is 4, that is 5 plus 4R minus 4, that is 4R plus 1. 4R plus 1, 4R plus 1. This is the rth term. Now the next is next sequence, second number in the product are in the product are 7, 11, 15, which are also in AP whose first term is 7, whose first term is 7, common difference is 4, whose first term A is equals to 7, common difference D is equals to 4, hence the second number in the rth product is equals to T suffix R is equals to, that is A plus R minus 1 into D. The value of A is 7 plus R minus 1 into D. The value of D is 4. Therefore, it is a 4R plus 3. It is a 4R plus 3, and it can be written as like this, that is a 7 plus 4R minus 4, which is 4R plus 3. And their summation is written as like this now. Therefore, rth term is equals to 4R plus 1 into 4R plus 3 and their product, that is a 16r square plus 12r plus 4r plus 3 and 16r square plus 16r plus 3. Therefore, overall it is written as like this: 5 into 7 plus 9 into 11 plus 13 into 15. There must be, I had made mistake there, that is the difference is only 4. Is in place of 14, there must be the 13. Therefore, up to the n terms, in place of 14 there must be the 13. Therefore, summation r is equals to 1 to n t suffix r is equals to 16 r square in bracket 16 r square plus 16 r plus 3 16 r plus 3. Now evaluate this, that is the 16 into summation of the r square, summation of the r square, r is equals to 1 to n plus 16 into summation of r plus r is equals to 1 to n plus 3 r is equals to 1 to n and it can be written as like this: 16 into n plus 1 into 2n plus 1 plus n. Next is, that is the first is 16 into n plus 1 upon 2 plus 3n. Now simplify normal. This is the final answer. Now the problem number 6. Find now there is again problem. Find the sum 2 raised to 2, 4 raised to 2, 6 raised to 2, 8 raised to 2 up to n terms that is the 2 raised to 2, 4 raised to 2 plus 6 raised to 2 plus 8 raised to 2 dash dash. Now these all the terms are the sum of the squares of the even terms and it is written as like this: r is equals to 1 to n 2r bracket square. That is a 2r bracket square again can be written as 4 in bracket 4 summation r is equals to 1 to n of the r square. And what is the r square? That is n into n plus 1 in second bracket 2n plus 1 upon 6. And that's why we are getting that is a 2 dot n in n plus 1 to n plus 1 upon 3. Instead of 6 there must be 3. Now next Find 70 square minus 69 square plus 68 square minus 67 square plus 66 square minus 65 square, and in this way up to the last term. In the last example, the divided by is 3 and not 6. Again I am repeating. We will say that sir, there is 6 numbers, it must be 3 there. Next is that is the 70 square minus 69 square plus 68 square minus 67 square plus 66 square minus 65 square and the last is 2 square minus 1 square. Now we'll make the separate terms, that is the 70 square plus 68 square plus 66 square plus dash dash minus 69 square plus 67 square plus 65 square and to the last. Therefore, R is equals to 1 to 35 summation 2R bracket square minus summation R is equals to 1 to 35, and all the numbers are the odd numbers, that is the 2R minus 1 bracket square. Now 2R square means what? It is a, we can take again their summation common, that is it will be again simplified form R is equals to 1 to 35. 2R square, 2R bracket square means what? 4R square, and 2R minus 1 bracket square means what? 4R square minus 4R plus 1. Now plus 4R square and minus 4R square get cancelled. Therefore in bracket you will get 4R minus 1, and the summation 4 into R is equals to 1 to 35 of the R minus summation R is equals to 1 to 35 of the constant, and summation of the R is 35, that is R into R plus 1 upon 2, that is a 35 in bracket 35 plus 1 upon 2 minus 35, and these are the calculations, that is a 35 into 36 into 2 minus 35, and overall we are getting the 35. Take the common, that is a 2 into 36 minus 1, that is 35 in bracket 72 minus 1, which is 71. Therefore it is the product of 35 and 71 is 2485. 2485. Now the next is find the sum, that is 1 into 3 into 5 plus 3 into 5 into 7 plus 5 into 7 into 9 up to the dash dash. Therefore all the 3 terms now, each term, that is a 1, 3, 5, the first number, each series is a product of the 3 numbers. The first number in product are 1, 3, 5 dash dash. They form the AP, that A is equals to 1, D is equals to 2, and therefore we can write here the numbers a plus r minus 1 into d. There are the term a plus r minus 1 into d, that is a 1 plus r minus 1 d. The value of the d is a 2, which is 1 plus 2r minus 2, that is a 2r minus 1. Now see the second number. In second number, the first term which is the 37357. Therefore, a is equals to 3, d is equals to 2. Therefore, the rth term is 3 plus r minus 1 into d. That is a 3 plus r minus 1 into 2. That is a 2r plus 1. And the third product number, that is a 579. In this case, the first term is 5, common difference is 2. Therefore, the rth term is 5 plus r minus 1 into d, where the value of the d is 5 plus r minus 1 into d, d is 2. That is 2r plus 3. And in this way, we have the product of the terms. This is the third one. Therefore, 1 into 3 into 5 plus 3 into 5 into 7 plus 5 into 7 into 9, and their terms can be written as 2 n up to the n terms, that is a summation r is equals to 1 to n, dr is equals to 2r minus 1 into 2r plus 1 into 2r plus 3. That is summation r is equals to 1 to n, 2r minus 1 into 2r plus 1 into plus 3. Now their products are, that is a 4r square minus 1 into 2r plus 3. Now make their product also. That is, you will get r is equals to 1 to n, 8r cube plus 12r square minus 2r minus 3. Now their simplification is 8. Summation r is equals to 1 to n of the r cube plus 12. Summation r is equals to 1 to n of the r square minus 2. Summation r is equals to 1 to n of the r minus 3. Summation at the constant, that is 8 into summation r cube, that is n into n plus 1 upon 2 whole bracket square. Summation, that is a 12 n into n plus 1 into 2n plus 1 upon 6 bracket complete minus 2 n into n plus 1 upon 2, and the summation of the one, that is a n. Therefore, the terms are 8 into n square in bracket n plus 1 upon 4 plus next simplification, that is a 2 in bracket n into n plus 1 and 2n plus 1. 2 again get cancelled, that is n into n plus 1 minus 3n. Now the next simplification. In this case, that 8 upon 4, that is a 2 n square in bracket n plus 1 bracket square plus 2n in bracket n plus 1 to n plus 1 minus n into n plus 1 minus 3n minus n into n plus 1 minus 3n. Now again the answer is a different one, therefore I had written up to this. You can simplify or keep it as it is also. This is the answer. Next, number 9. If 1 into 2 plus 2 into 3 plus 3 into 4 plus 4 into 5 up to nth term, they are like this: 1 plus 2 plus 3 up to n terms. They are 100 upon 3. Find n. Now in this case, we want to find out the value of the n. Now see this very simple problem, that is 1 into 2 plus 2 into 3 plus 3 into 4 plus 4 into 5 up to the n terms, and to the denominator 1 plus 2 plus 3 up to the n terms upon 100 upon 3. Now to the numerator we have r is equals to 1 to n. The terms are r in bracket r plus 1, and the denominator are again very simple, that is the sum of the r is equals to 1 to n, 100 upon 3. Now summation of the r square plus summation of the r square plus r upon summation of the r is equals to 1 to n, 100 upon 3. Therefore you will have that is equals to 100 upon 3. Therefore r is equals to 1 to n, r square summation r is equals to 1 to n of the r upon summation of the r, 100 upon 3. Now substitute the values: n into n plus 1 in bracket 2n plus 1 upon 6 plus n into n plus 1 upon 2 upon summation of the r, that is n into n plus 1 upon 2 is equals to 100 upon 3. Now the simplification. N into n plus 1 upon 2. If you take the common, then in bracket you will get 2n plus 1 upon 3 plus 1 upon n into n plus 1 upon 2. Now this is n into n plus 1 get cancelled to the left hand side, numerator and denominator, that is we get, that is a 2n plus 1 upon 3 plus 1 is equals to 100 upon 3. And now simplify this, that is a 2n plus 1 upon, that is a 2n plus 1 plus 3 upon 3, that is 100 upon 3. 3 get cancelled on both sides, that is a 2n plus 4, 2n plus 4 is equals to 100. Therefore 2n is equals to 100 minus 4, that is a 2n is equals to 96, and therefore n is equals to 96 upon 2, that is equals to 48. The value of the n is 48. Now we will see the next last problem. Next, problem number 10. If S1, S2, S3 are the sum of first n natural numbers, their squares and their reciprocals. S is for the sum of the natural numbers, second is their squares, and third is their reciprocals, their cubes respectively, because the last example was like this. First is sum of the natural numbers, second is their squares, and third is cubes respectively. Then show that 9s2 square is equals to s3 in bracket 9s2 square is equals to s3 in bracket 1 plus 8 into s1. Now see this, s1, s2 and s3 are the sum of first n natural numbers, their squares and their cubes. That is, this was the starting phase of this problem. That is a summation of the natural number, their squares and their cubes. Therefore, S1 is equals to R is equals to 1 to n, summation of the R, n into n plus 1 upon 2. So I have to substitute only the values. S2 is equals to R is equals to 1 to n R square, that is n into n plus 1 in bracket 2n plus 1 upon 6. And the last is S3, that is summation R is equals to 1 to n R cube is equals to n into n plus 1 upon 2 whole bracket square means what, n square, n plus 1 bracket square upon 4. Now consider the RHS here. That is, again writing the IMR. RHS is equals to S3 in bracket 1 plus 8 into S1. Substitute the values. That is a n square in bracket n plus 1 bracket square upon 4, 1 plus 8 into S1, that is a n into n plus 1 upon 2, and now simplify this, that is a n square in bracket n plus 1 bracket square upon 4, and which is 1 plus 4n in bracket n plus 1. Now simplify this, that is a n square in bracket n plus 1 bracket square upon 4. After simplification bracket you will get 4n square plus 4n plus 1. Now n square in bracket n plus 1 bracket square. Now see this, it is a perfect square, that is a 2n plus 1 bracket square, which is equals to, that is a 9 upon 9, we are adjusting there. Therefore, this is nothing but the 9n square plus n plus 1 bracket square into 2n plus 1 bracket square upon 9 into 4, that is a 36, which is in bracket can be written as n into n plus 1 into 2n plus 1 upon 6 and whole square, and that is nothing but the 9s2 square, and this is our LHS. Therefore, LHS is equals to RHS, that is a 9s2 square in bracket s3 in 1 plus 8s1, and hence we have completed this chapter totally, big one, and the very tough calculations are there, but it is very easy if we do. In this way we have completed the exercise 2.6. I hope that you have understood all the problems, whatever that I had explained. If you like it, then like it, and if you are new for this channel, then subscribe it and share it with your needy friends. Now we'll see the next chapter. Till then, goodbye.